Hi everyone, welcome to another Jacobs video tutorial. I'm Jennifer, a student supervisor for the Jacobs Institute, and today I'll be giving you all a rundown of the different manufacturing methods offered at Jacobs Hall. For the newer maker, the options can get a little overwhelming, but we'll break everything down into 3 parts to get you started: modeling, additive versus subtractive manufacturing, and 2D cutting. It's always great to keep in mind the overall workflow of your project as you start designing. Start with modeling, then identify your fabrication method, format your files accordingly, send your files to the machine, and post-process all of your parts. If you're designing your files for remote fabrication, your work will end at file formatting. Jacobs Project Support, or JPS, will take your files from there and fabricate your designs according to your specifications. Your first step, which is the modeling process, is one of the first tasks addressed and is key to visualizing the many geometries at play. There are 2 important categories of software to be familiar with: CAD and CAM. CAD, or computer-aided design, is great for creating 3D solids and surfaces and even 2D curves. A few great options for CAD software are Fusion 360, SolidWorks, and AutoCAD, each of which have their own set of strengths and weaknesses. Fusion 360 is cloud-based, which makes it easy for collaboration, has a beginner-friendly user interface, and may be installed for free with a berkeley.edu account. Fusion also handles freeform models very well and allows for multi-component models, which means that you can have many components of a system existing within the same file. Fusion 360 can also simulate basic movements using their animation joint options. Last but not least, Autodesk is widely used and has a great online user community. SolidWorks has strong 3D modeling capabilities, unmatched simulation options, and a friendly user interface. It is great for assemblies where each part is modeled individually before assembled in a separate file. SolidWorks also has a great online user community for help and support. AutoCAD has strong 2D sketching capabilities, but it can also handle 3D models as well. This software is especially great for modeling electrical systems using its electrical module. While AutoCAD has a more crowded and complicated user interface, this software provides high flexibility and freedom for 2D sketches. CAM, or computer-aided manufacturing, on the other hand, emphasizes the automation of manufacturing and fabrication. CAM works to create paths to control your machine during the cutting, milling, routing, or engraving process, yielding highly accurate cuts by converting your models into G-code that a machine can read. The CAD and CAM lab at Jacobs Hall offers a variety of software options for users, including the 3 we discussed before. Head over to jacobsinstitute.berkeley.edu for a thorough list of software. CAD and CAM go hand in hand. In fact, Autodesk Fusion 360 is built with CAM integrated into the software for easy manufacturing. Together, CAD and CAM allow for us to create detailed designs and then automate the fabrication of these designs using computer-controlled machinery. You might be wondering what kinds of machines we can use to actually make our designs a reality, and this leads us into our next part: additive versus subtractive manufacturing methods. Additive and subtractive manufacturing are a lot like what they sound. Additive manufacturing involves the deposition of material one layer at a time to create an object, and this works really well for making small detailed parts. At Jacobs, there are many 3D printing options available, including material extrusion and resin printing. The material extrusion options, like the Ultimakers and Type A printers, are bottom-up printers which deposit layers from the base up. These standard printers are tunable for both low and high quality prints, have an easy user interface, and have minimal safety hazards. The resin printer options, like the Formlab Form 3 SLA, use a laser to cure resin layers, supporting both bottom-up and top-down manufacturing. These printers can host a variety of resins, including elastic, flexible, tough, and temperature-resistant resins to meet different project needs. For projects that need a boost in strength, the Markforged X7 weaves in a continuous fiber of carbon fiber, Kevlar, or fiberglass into the filament during printing. This continuous fiber reinforcement printer can print pieces of nylon and onyx with strengths of industrial metals. Subtractive manufacturing, on the other hand, involves the removal of material from bulk, leaving behind the object. Unlike additive manufacturing, this method works really well for larger, less intricate designs. This type of manufacturing typically involves a spindle which spins a cylindrical cutting bit that can be moved in the X, Y, and Z direction to remove material where it's not wanted. Different machines vary by material limitations, space envelopes, spindle speeds, feed rates, tool speeds, and tool diameter. So picking the right CNC machine and adjusting these speeds for your material and project will enhance the quality of your part. Some options for subtractive manufacturing at Jacobs include CNC machines like the ShopBot CNC router and the Tormach. The ShopBot CNC router can cut wood. Contact a design specialist for specifics regarding the limited plastic and foam options. Metals, composites, and carbon fibers are prohibited. The ShopBot has a working envelope of 96 inches by 48 inches by 6 inches. The Tormat can cut standard metals like aluminum and steel and hard plastics like Delrin, acrylic, nylon, and polycarb. Carbon fiber, fiberglass, woods, and PVC are prohibited. The working envelope is 10 inches by 6.25 inches by 10 inches. 2D cutting is another widely used fabrication method, especially when dealing with 2D sketches and planar materials. The speed and accuracy of 2D cutting makes it very appealing for quick prototyping as well as final projects. 2D cutting can happen in a variety of methods. Some cutters use lasers, others use pressurized streams of water. The 2D cutting options at Jacobs include the universal laser cutters, the FabLite, and the Omax waterjet. All of these machines accept 2D vector files, which can be prepared in programs like Adobe Illustrator. If you're unfamiliar with how to prepare these files, don't worry, check out the tutorial link below to get started with 2D file prep in Adobe Illustrator. Each machine has specific material restrictions that may affect your design choices. The universal laser cutters are suitable for cutting and etching sheets of wood, acrylic, paper, certain fabrics, glass, and rubber. The 3 lasers in 110 have a bed size of 32 by 18 inches, and the laser in 120 has a bed size of 48 by 24 inches. Wood and acrylic in a 1/4 inch and 1/8 of an inch are the most common materials you'll find in our universal machines. The FabLite laser is suitable for cutting and engraving metal sheets of steel, stainless steel, aluminum, copper, brass, and titanium, as well as tubes of stainless steel and steel. This laser may not cut any wood, plastic, fiberglass, or carbon fiber. This laser has a bed of 50 inches by 25 inches. The Omax waterjet can cut the most diverse range of materials, including metal, like aluminum, copper, carbon steel, composites, like carbon fiber and fiberglass, plastics, like acrylic, polycarb, plexiglass, and natural materials like wood, glass, and ceramics. Note that the materials cut within the waterjet will be wet by the abrasive mixture used to cut. Being able to identify and decide between different manufacturing methods allows for us to pick the most efficient route when it comes to fabricating. If your design requires strength or high production rate, consider laser cutting over 3D printing or milling. If you need parts that are smaller, more detailed, or depend on 3D curves and undercuts, consider 3D printing instead. If your design is easier to machine using a mill or you have a piece of material you want to machine, opt for milling. Remember that the maker community is huge and resources are abundant. For more information about the topics we covered today, feel free to reach out to me, the Jacobs staff, or the maker community. For more specific information regarding what is most suitable for your project, consider contacting a design specialist and scheduling a one-on-one appointment. Thank you for watching this video. I hope it was helpful to you. For more tutorials, workshops, and maker-related content, check out our website, jacobsinstitute.berkeley.edu, and our YouTube channel. Please stay safe, keep making, and go Bears.